All right, moving on here with our topic of exponential and logarithmic functions. Now I want to move on to, again, the definition of logarithms. When I'm back to that, as I mentioned earlier, the most important thing we write down today is what a logarithm is. As we mentioned, a log is an exponent. Log base a of x equals some number y if and only if a to that y power equal x. So again, our question is what power to raise our base to get x. And remember, x has restrictions. It must be a number greater than 0. A is a base that's greater than 0, not equal to 1. Now, to help us with these examples, with this definition, let's do some examples. It says here to write the following in exponential form. All right, so for example, log base 2 of 8 equal 3. So here we've got log base a of x equal to y. So we want to convert it to a to the y equal x. So there's our exponential form, right? So we've got a logarithm. Let's use our definition and get the exponential. So that implies a is 2 to the third power equal 8, right? 2 cubed is 8. And you can label it if you want till you get used to it. Again, log base a of x equals some number y. A to the y is x. So again, there's a to y equal x. Now, I want you to look at example B. Now, example B includes one of our special bases, what we call a common logarithm. So I'm going to write that up here above that. All right, a common logarithm is a logarithm with a base of 10. All right, so a common logarithm is a base 10 logarithm, log base 10. So, and that's abbreviated LOG. So we see here we got LOG. This is log base 10 if you want to write the base. So here it is, log base a of x equal y. So it says convert that over to an exponential. So as we look at that, again, our base, here's a, right? Here's x, and here's y. So that implies a to the y is x. So let's write a to y equal x. So 10 to the y power, which is 10 to the negative 2 power. What our log equals is y, our value. And what we're taking a log of is x, right? So 10 to the negative 2 power is equal to 1 over 100. And that's true. 10 to the negative 2 power is 1 over 10 squared, which is 1 over 100. So you can see these do check, right? 2 cubes, 8. 10 to the negative 2 power is 100. Now, as we look at example C, this introduces, again, another special logarithm. We see the abbreviation of ln. ln is our abbreviation for our natural logarithm. So earlier we studied our natural numbers. We looked at natural exponential functions. So at logarithm base e, we abbreviate ln. Base e. Natural logarithm is a logarithm of base of e. So again, if you wanted to, you could rewrite this. This is log base e of x equal to 1. So again, as we're converting to an exponential, right? We've got here's x, here's y. So our equivalent exponential is e to the 1 power equal x, right? If e to 1 equal x, we know log base e of x equal 1. A to y is x, log base a of x is y. So again, I'm using my logarithmic definition going from here to there, right? Just rearranging it. So remember, logarithms are exponentials. So what our logs equal, that's our exponents on our base. What we're taking a log of is what we're equal to. A to the y equal that number x. Let's go the other way. Write in logarithmic form. So now we're going to take a to the y power equal to x, and we're going to convert it over to log base a of x equal to y. So we want to get the logarithm back. For example, we all know 6 squared is 36. What's its equivalent logarithm? So here's a to the y equal x. There's a, there's y, there's x. So that's log base a, log base 6 of 36 equals what? Our power. Our power is 2. Log base a of x equal y. Yeah, log base 6 of 36 equal to 2 because, 6 to the 2 power is 36. Same thing here, a to the y is x. What's our equivalent logarithm? Let's go ahead and convert it. That's log base 4 of 4 equal to 1, right? A to the y is x, log base A of x is y. So again, just rearranging it. If you need to label your parts, you can label your parts. Again, you can write your logarithm out. Log base A of x is y. So yeah, log base 4 of 4 is 1, because 4 to 1 power is 4. And our next one, we got 10 equal to e to y power. So here's our natural number. So we convert it to a logarithm. We're going to have a log base e, our natural number, which we can abbreviate ln. Again, here's x. So log base e of 10 equals y. And again, the same thing as saying the natural log of 10 equal y. So there's our equivalent logarithm. Log base e of 10 is y. A to the y is x. Log base A of x is y. All right, let's find the exact value of a log without using our calculator. So let's look at, for example, log base 9 of 81. So log base A of x equal what? Some number y. Our question, what is that number y here? So we'll go ahead and rewrite it. So 9 to what power equals 81? Well, we know it's 2. 9 squared is 81. I want to also show you can prove this, right? Even using exponentials. So, for example, we want to find y, right? You can, if you want, rewrite this with the same base. So I'm going to rewrite both sides, base 9. I know that 81 is 9 squared. So again, if 9 to the y power equal 9 to the 2 power, we can drop down the exponents and set those equal based off exponent properties. So yeah, what is log base 9 of 81 equal? Log base 9 of 81 is equal to 2, because 9 squared is 81. And I've proven that even using exponentials. What about b? I got log base 5 of 1 equal what? So again, our question is this: 5 to what power equal 1? Well, we know 5 to the 0 power is 1. So as we're looking at this, as we're writing down our answer, we know this is 0. Yeah, the log of 1 is always 0. Doesn't matter the base. Take any base greater than 0 not equal to 1. We raise it to a power of 0. Output going to be 1. So yeah, 5 to the 0 power is 1. What exponent we raise our base to get x? How about example C? All right, what is our output? 3 to what power? Let's go ahead and assign the variable y. Let's write the exponential statement. 3 to y power equal 1 over 81. Let's find y. Now you might not see it, but that's okay if you don't. Let's use our same base property again with exponents. We always try to get the same base, and we can drop down the exponents. Well, I know that 81 is a base 3 number. I know that 81 is 3 to the 4th power. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. With that said, now I've got both sides base 3. The only thing I want to do is go ahead and bring that up, get rid of the fraction. And we do that, we have to change the sign of the exponent. And now, since our bases are equal, we can drop down these exponents and set them equal. So yeah, y, our value of this logarithm, is equal to negative 4. So let's go ahead and write in our answer. So log base 3 of 81 equals negative 4, because 3 to the negative 4 power is 1 over 81. How about log of 1,000? So again, remember, this is a logarithm base 10. So 10 to what power, we'll call it y, equal 1,000. Let's find y. So with that, log base A of x equal y to y is x. Well, again, I want to prove it. Rewrite y, or rewrite 1,000, base 10. Let's get the same base again. We all know 10 cubes, 1,000. So yeah, y equal 3. So yeah, log base 10 of 1,000. Log of 1,000 is a common logarithm. They didn't have to write that base of 10. You notice they abbreviated, which is log. We have 10 cubes, 1,000. In example E, now this is a natural logarithm, so it might help you. If you look at example E, this same thing is saying log base E of E equal what number? What number y? So our question, e to what power y equal e? Well, we know that would be 1. Y would have to equal 1, right? So yeah, natural log of e is 1. And this is true with any logarithm with the same base is what you're taking a log of. Right? Log base A of A will always equal 1. That's one of our log properties. Just like log of 1 is always 0. Looking at last example here in F, log base 4 of 2 equal what number? Let's find that number y. So again, as we're doing example F, we've got 4 to what power y equal 2. Well, like we've been doing, let's write both sides the same base. We all know that 4 is 2 squared. And we all know that power to a power in math, we multiply those exponents. Well, now I've done exactly what I want. I've got both sides written base 2. So once the bases are equal, we can drop down the exponents and set those equal. And if 2y is equal to 1, as we solve for y, we get y equal to 1/2. So our logarithm, base 4 of 2, what power do you raise 4 to get 2? 1/2. And yes, that's true. We know that 1/2 is the same thing as saying square root. We've got an exponent. If square root of 4 is 2. But I'm proving that just using my log definition. Remember, logarithms are exponents. So I'm looking at them as exponential statements as I look at evaluating these logarithms.